Good evening, ladies and gentlemen. A warm welcome to one and all present in the first ever virtual conference named and styled as Aerocon 2020. I have a great pleasure to introduce the overview of Aerocon 2020. This is going to be a power packed 2 day technology exposition, will be followed by a sequel of events. A little bit of a background how we conceptualized this event. This event was well thought sometime mid of last year, and we swung into action sometime third quarter of 2019. In our minds, we want to bring an exclusive exposition or an event specific to aeronautical or aerospace members. In our minds, the synonymic model apparent at that point of time was a flagship event by SA International called Aerotech. Since then, we have decided and started working on this event. Our original plan was to host this event in Bangalore. Of course, we all know that some changes in the business climate due to a tiny COVID virus. The situation was pandemic, so we need to rework ourselves. As an interim, we decided not to halt this program, but we wanted to do it in a hybrid format. It's like this, we want to host the main event in Bangalore with a limited access to the speakers and key participants, and create some satellite centers in Hyderabad, Pune, and in Chennai. But even this was not possible. So we have to completely rework. We went back to the drawing boards. And finally, we decided to take this program completely virtual. Then we put a lot of efforts. We found various committees. Very interestingly, we need to plan this program also virtually. After the initial meeting in February, we did all the arrangements without seeing each other face to face. That was the highlights of this event. I want to give three important points with regards to the Aerocon 2020. Number one, creating awareness about SAE organization. More specifically, the role of Aero Forum in SAE India, dedicated to the community of aeronautics. As you all know, SAE India exists in the country for several years, and we have a direct affiliation with SAE International. SAE International enjoys a heritage with the core strength of a well-known technology consortium, more importantly, known for its the organization for standards. In fact, SAE standards emanated from aerospace practice. Today it's serving all forms of mobility. The second point on the first theme, focus is India. India is an emerging market, as well a great place to accelerate the engineering process through its capacity, agility, and faster skill adaptation. This has proven in several business practices, namely software, automotive. But here comes the challenge. Aeronautics and aerospace, we cannot draw parallel with these success. We definitely lack the experience at par with the developed countries. So that puts us into a challenging position to create a technological platform to showcase the experience and expertise available globally and with the local experts. Our goal is to create a platform to make this exchange to happen fruitfully. Also, we need to seize these opportunities. Today, India is in the global map, especially in the aeronautical, aerospace, both in civilian and defense opportunities. In order to convert all these opportunities into business, we need to really face these challenges. They are quite tough and sustain in business. There are several hurdles to cross. The second priority for us is to increase aerospace domain knowledge and the skill quotient. In India, in the aeronautical domain, we have a very rich heritage from the Indian Air Force and, and DPSUs and collaborations with the European and American aeronautical airframers. Our experience so far is very good in partnering, doing engineering, and licensed manufacturing. But this is not enough for a sustainable aeronautical and aerospace organization, either in the form of civil or in defense. We need to nurture our organic technological development, then engineer this technology to an airworthy flying bird. Definitely, we face some crisis in terms of domain knowledge and skills in this area. We are committed to lay the foundation stone to create a self sustainable ecosystem. We need a strong foundation. That is where you see India took a pledge. We have been serving for the last 10 years or more in delivering various technology related programs, skill enhancements, large format expositions and conference and workshops. The last but not the least, uh, our strength is our numbers as well. India is blessed with a large population, including engineers. At the same time, we have a great responsibility to qualify these raw skills at par with global standards. So the third important responsibility comes how to help the community of yet to be engineers, namely students, right from their young age, practicing engineers, and academia. I just want to mention in this forum that they say India got a great network of students, association with universities, ranging from high schools, polytechnics, engineering colleges, and universities. So ACE India Aero Forum will definitely take advantage of this network, access to the needs, and connect to the international and local expertise. Other important.
Thank you, Damo. Thank you for your overview of. Thank you, Damo. Thanks for the overview of Aerocon 2020. Gentlemen, now is the time to move on to the next speaker, very important speaker. And before that, for those who are new to the SAE world, it's my duty to tell you what we do. SAE International, based out of Warrendale, Pittsburgh, US, is governed by a board of directors headed by the president, who also serves as a chair of the board. The board supports society's mission of serving a global network of mobility engineers by providing industry standards and lifelong learning, networking, and career development opportunities. Interestingly, it's a limited opportunity to have SAE International President from the aerospace industry in 2020. And this year, it's a rare coincidence that we have President of SAE International and President of SAE India from the same organization, Boeing Corporation. We at SAE India are more than delighted to have current SAE International today. Mrs. Arforce is responsible for engineering functional organizations and the Washington State Design Centers for all commercial airplanes. In his role as Senior Chief of Airplane Systems, he is responsible for driving technical excellence within the airplane systems community. Previously, Zarfors served as Vice President of 7478 Engineering and Senior Chief Engineer of Airplane Systems. Mr. Zarfors has served in other key leadership positions throughout his career at Boeing, including Vice President of Engineering for the 747, 767, 777 programs. He was also Vice President for Product Development for Boeing Commercial Airplanes and Chief Project Engineer for the 777 program. He holds bachelor degree in engineering, electrical engineering from University of Minnesota and a Master of Science in electrical engineering from the University of Washington. Mr. Zarfors is a fellow of American Institute of Aeronautics and Astronautics, AIAA. He is also a fellow of the Royal Aeronautical Society. He also serves on the RTCA Board of Directors. We are indeed very glad to have Mr. Todd Zarfors, President, SAE International 2020. Over to you, Mr. Todd. Townscript team, can you take Mr. Todd Zarfors on the stage, please? I can be off the stage. Prabhakar?
countries for 2021 and 2022. Autonomy, electrification, and connectivity continue to dominate the automotive market as partnerships and technological advancements create value for brands and consumers alike. Additionally, in the commercial vehicle industry, trucking employment has not yet recovered to pre-pandemic levels. Production and sales of North American Class A trucks dropped heavily in the first half of this year, but we are seeing rebounds as we move into the third quarter. Based on discussions with some of the leading commercial vehicle experts, they note that the pandemic is accelerating the transition to a more digital future. Digital has been forcing organizations and individuals further up the adoption curve to move more quickly. Similarly, digital channels are becoming the primary customer engagement model, and automated processes are a primary driver of productivity. While not the direct theme of today's conference, I find it instructive, if not, that we are experiencing in the aerospace industry is not a singular or isolated event. In fact, we are an ecosystem, and we can and are learning from one another. So how has the aerospace industry sector reimagined itself in a post-COVID era? As the theme of Aerocon so aptly states, one of the primary areas of focus has been on restoring confidence in the flying public in commercial airplanes as being safe for travel. Just last week, the United States Transportation Command released the results that the overall coronavirus is very low in the airplanes that they tested. This is some welcome good news for the commercial aviation industry, reinforcing that airplanes provide a safe environment for passengers.
Thank you, Mr. Todd Zarfos, for your support. It was a privilege to have you in Aerocon 2020. The next executive leads several organizations of SAE Enterprise, someone who nurtures long-term relationship with India, an executive with good grip on operational details and strategic vision, a quality which is rare amongst the chief executives. A CEO who understands the cultural diversity, members' needs, and navigate well with various committees within SAE International, Dr. David Shutt. Dr. David Shutt is the CEO and oversees global management and operations of the $150 million SAE Group, consisting of SAE International, Performance Review Institute, SAE Industry Technologies Consortia, and several other subsidiaries and joint ventures. SAE is the world's resource for designing, building, maintaining, and operating self-propelled vehicles for use on land or sea, in air or space. Performance Review Institute is a trade association that advances the interests of industry through development of performance standards and administration of quality assurance, accreditation, and certification programs. SAE Industry Technologies Consortia is a trade association with a mission to build industry infrastructure tailored to the respective technology, market, and industry member groups. Dr. Shutt serves on variety of not-for-profit and for-profit boards, national commissions, and local business organizations. Prior to joining SAE International in 2007, Dr. Shutt worked at the American Chemical Society in several executive management positions. Dr. Shutt holds a doctorate in physical chemistry from Princeton University and a bachelor degree from Calvin College. He also earned an MBA from Johns Hopkins University. Over to you, Dr. David.
Thank you, Todd, and good evening to my fellow distinguished speakers on the dais, Dr. Bala Bharadwaj, Mr. Damodaran, and Mr. Muniratnam, and to the members of the Steering and Organizing Committee, distinguished guests, ladies and gentlemen. My name is David Shutt, and I'm the Chief Executive Officer of the SCE Group, of which SCE International is a part of. It is a professional honor for me to be a part of this auspicious and inaugural event. And as a matter of personal pride, as I have advocated for SCE India to step into the leadership role for the aerospace industry within India. And through this event, they have, and congratulations. As some of you already know, SCE International is a global membership association committed to advancing mobility knowledge and solutions for the benefit of humanity. As Todd previously noted, we work in the aerospace, the automotive, and the commercial vehicle industries. Each year, we engage hundreds of thousands of engineers, technical experts, and volunteers to advance mobility knowledge and solutions. And we do this through standards development, engineering events, technical publications and research, pre-professional and professional development, and our SCE Media Group publishes a variety of magazines, including the Aerospace and Defense Technology magazine. Now, throughout this turbulent year, we have shifted our approach to engage with our stakeholders in the most impactful and convenient ways possible. Like all of you, we've reassessed our value propositions and our value chains in service of our members, our stakeholders, and our customers. Perhaps most importantly, we have shifted our focus to a digital-first model. By embracing digital platforms and virtual engagements, SCE continues to guide the aerospace industry and to help connect and engage engineers that allow them to innovate and ideate. One of the most important things that we've been doing this year is engaging the aerospace engineering community to continue to develop standards for the entire aerospace industry. We've also been leaning more fully into the future and looking at other forms of air mobility, including eVTOLs. Our events have shifted from an in-person to a virtual and, where possible, hybrid events. Through these transformed events, we continue to serve as the anchor point for industry to gain insights and connections from their peers. As we look forward into next year, we are looking at how we can best present our annual and seminal Aerotech in March of 2021. We want to ensure safety for all of our attendees, and we also want to deliver unquestionable value and networking opportunities where the aerospace industry can be advanced. These are all reasonable expectations, and we believe we can deliver them. Now, as I previously noted, SCE International is part of the SCE Group. This digital virtual shift in delivering stakeholder value is also true for our sister organizations, the Performance Review Institute and the SCE Industry Technologies Consortium. Everything from conducting quality audits virtually to accelerated utilization of blockchain, we are ensuring the integrity of the aerospace supply chain. Clearly, virtual and possibly hybrid is here for a long while, and we will continue to tune our portfolios to meet the evolving needs of the aerospace industry and our stakeholders. I'd like to conclude my remarks with a strong note about SCE India and Aerocon itself. SCE International proudly maintains a long-standing relationship with SCE India. Through our Memorandum of Understanding, we continue to support both aero and ground vehicle activities as we advance mobility knowledge around the world. We are also able to bring India talent and technical expertise into our programs, products, and services. And throughout India, in partnership, we were able to advance student learning and mobility learning. And finally, we're able to partner and deliver important events like Aerocon. To all the Aerocon organizers, participants, and distinguished guests, please accept my gratitude for the opportunity to participate with you this evening virtually, and I wish you all the best and great success in the virtual conference. Thank you.
Thank you, David. I think it was an inspiring and straight from the heart talk as usual. And I want to take this moment to thank you from all of us in SA India for all the support to you and Murli. Ladies and gentlemen, it's time to listen to the CTO of ANSYS, our title sponsor, Dr. Prith Banerjee. Dr. Prith Banerjee is a Chief Technology Officer at ANSYS, a leader in engineering simulation. In this role, he leads the evaluation of ANSYS technology and champions the company's next phase of innovation and growth. Dr. Prith has served Conferry, Schneider Electric, Accenture, ABB, and HP prior to joining ANSYS. He was also an academician. He has served the University of Illinois and Northwestern University. So a combination of academician and industrialist is coming to you. Dr. Prith's research interest are in electronic design automation and parallel computing. He is the author of over 350 research papers. He has also supervised 37 PhD students. He has received his from IIT Kharagpur and MS and PhD in electrical engineering from University of Illinois, Urbana. Over to you, Dr. Prith Banerjee, Chief Technology Officer of ANSYS.
Good evening, everyone. Thank you for joining us today. My name is Prith Banerjee. I am CTO at ANSYS. I'm going to talk to you about simulation's critical role in aviation today and tomorrow. I joined the company about 2 years ago, and my responsibility is to set the long-term technology directions for ANSYS. Prior to ANSYS, I used to be CTO at ABB and Schneider Electric, and before that, I was director of HP Labs. The airline industry is facing tremendous challenges, as you all know. There's about a 2/3 decline in world air traffic, and there's about a third of the world jet fleet is unemployed, right? And so the question that everybody's facing in the audience today is, how do we drive cost out of operations to save money today, as well as to be profitable in the future? So the aviation industry is facing tremendous challenges. Now, if you take a look at where the cost goes in the airline industry and in other industries, it's kind of interesting that when you look at the 3 phases of a product life cycle, there is a development phase, there's an operations phase, and a maintenance phase. And you look at the total life cycle cost of a product in the airline industry, about 30% of life cycle cost is consumed before start of production. So essentially you have committed 90% of the cost of the total life cycle cost is committed at the start of production, which is very, very important. And so you have to do it right? During production, what happens is this ideation. You're thinking about the different aircrafts and how it will be done, the conceptual phase, the detailed designs phase, the simulation phase, the testing phase, and then you enter the operations and maintenance area. And then there is obviously increased cost that happens, but the cost is actually committed for the whole time, right? And then you look at the total cost, 30% of the cost is the ideation and testing phase, 70% is the life cycle cost. So the role of simulation is actually to impact all of it, right? So when you look at in the aircraft industry, you spend a lot of time in physical prototyping, right? Now, if you don't have to do physical prototyping, you can actually save costs. So through simulation, people have said there's about 11% that you can do reduction in physical prototyping. You can reduce the development time by about 14%. You can do greater raw material utilization, greater OEE, operational equipment efficiency. So tremendous value in using simulation upfront in driving ideation, conceptual design, and verification of different products. So let me kind of share with you an example of how simulation can be used, right? We are all facing the COVID situation as aircraft's passengers try to enter an aircraft, right? The airline companies are trying to disinfect the cabins, right? With all different kinds of UV simulations and so on, lights and so on, right? And so what we have done is we have used ANSYS simulation. As you know, ANSYS has a lot of simulation capabilities from structural to physics to optical to light and so on. And we have used ANSYS simulation capabilities to work with our airline customers in helping to say, what is the cost of simulation, right? Using simulation, how can we do aircraft sanitation? So that's an example of the use of simulation. We can also look at the overall industry, right? The aviation industry is supposed to grow to about $7 trillion by the year 2030. So even though we are having a short-term dip in the aviation industry, long-term, the growth is very, very significant. However, we have tremendous sort of constraints where environmental constraints are happening, and people are saying you need to have the emissions by the year 2050, right? And so the people are exploring, should we use more electric aircraft or whatever, right? So all kinds of different things are being explored in the aviation industry to reduce environmental impact. And then you look at sort of the aviation professionals who are saying that as part of this journey towards the 7 trillion, right, and reducing environment, right, digital transformation is key. And what is digital? Using digital technologies like high performance computing, like cloud, like IoT, AI, machine learning, and so on. So use of digital technologies is going to greatly, greatly impact the airline industry. And simulation is a very, very important part of it. So then we have actually spoken to lots of aviation engineers, and they said that as part of this digital transformation journey, physics-based simulation is going to be extremely critical. And the top 3 skills that are needed in the aviation industry, right, are number 1, knowledge of AI and machine learning, and I will actually highlight that in my presentation. More use of better software engineering practices, and basically doing much better systems design. When I talk about systems design, it's starting from system level specification, the high level, going to the lower level, the V cycle that people do in system design. All 3 skills are going to be extremely important. So let me now kind of position as to how ANSYS is partnering with aviation companies in solving this problem. So this is a very simple overview slide of our simulation environment, right? So ANSYS does simulations, and we do fluid simulations, structural simulation, electromagnetic simulation. We take the physics of the world around us, which is governed by the second order partial differential equations, and we solve those equations very, very accurately through simulation methods, right? Like finite element or finite volume methods. So this is at the core of what we offer, and these solvers run on-prem, on the cloud, and we have all kinds of different materials properties that we can feed into different solvers through our Granta solver. And these solvers now being used to put together entire solutions for autonomy, for electrification of 5G and so on. So as you are exploring the design of electric helicopters or autonomous VTOL helicopters and so on, these are the kinds of solutions that ANSYS is actually partnering with aviation companies on. Now, as CTO at ANSYS, I am responsible for setting our long-term technology strategy. And I wanted to share a few of these strategic pillars with this audience, right? So at the heart of our solvers is we try to solve the physics of the world around us, right? If it's fluids physics, it is Navier-Stokes equations, and we want to solve them most accurately, right? But these solvers take a long time to run, right? And so what people do is they want simultaneously accurate simulations, they want fast simulations, they want robust simulations, and they want ease of using simulations. So what we are looking at is the use of AI and machine learning to actually address all of these issues. We are looking at simulation used to train AI methods and AI used to improve simulation. I have actually a slide that goes into a little more detail. The next thing that we're looking at is platform for multiphysics simulation, right? So in the previous slide, when I showed the different simulation capabilities, right, our structural solvers, our fluid solvers, our mechanical solvers, electromagnetic solvers, right? Essentially, what you need to do is to have those multi-physics interactions, like the fluid structure interaction, the fluid structure electromagnetics interactions, all happening. And these things need to happen on-prem and on the cloud, and they have to do it in a very, very fast manner, right? So we are building a platform called ANEED, which is going to essentially provide microservice for different tasks and simulation, like the meshing services, the fluid services, how do you submit jobs on a cloud, and so on. So very, very exciting effort. Third area is that of hyperscale simulation, which is around using of different forms of parallel processing, using shared memory multiprocessing, message passing, GPUs, task-based, and quantum computing to accelerate simulation. The fourth area is that of robust and predictive design. When you develop these aviation industry parts, right, and you base it on a particular type of steel or carbon nanotubes or whatever, right, you are assuming a particular materials property. The Young's modulus of steel should be 0.3212, right? And you use the solver to say, this is how this is going to solve. However, in practice, the material properties will be varying just a bit. So in the presence of uncertainties, how can you design products to be robust and predictive in the presence of uncertainty? So there's a lot of work that we're doing in this area. Moving to the right, we are exploring the use of sort of the convergence of the digital and the physical worlds. When you see the results of simulation, typically you see it on a 2D screen. Well, in the future, we are exploring the use of augmented reality, virtual reality in the presence of the engineers who can see through in 3D the output of simulation and use computational steering to explore new things. The IoT and connectedness is bringing the physical world to the digital world. And in the aircraft industry, people have talked about the use of digital IoT and sensors and so on. And so we are exploring a lot of those technologies as part of our ANSYS simulations. This brings us to topic number 6, which is on digital transformation. When you have a product, as I kind of mentioned, that in the design phase, the operate phase, the maintenance phase, right? You can think about the design phase digital thread, the operate phase digital thread, and the maintenance phase digital thread. And through simulation, you can actually provide continuity across all those threads in a design, right? And that's what this is talking about. And we have some really exciting work going on in the area of model-based systems engineering as well. Finally, we are looking at computational methods in new areas. So as I mentioned in the previous slide, we have capabilities for solvers in mechanical, in electromagnetics, and fluids. We are looking at the use of computational methods in materials engineering, where we will model things at the atomistic level, right? And do multi-scale simulation, tying in sort of simulation at the atomistic level to molecular levels to system level simulations. We are looking at new areas of like computational chemistry and so on to move into whole new areas such as healthcare. Finally, we are looking at the use of machine learning methods for solving partial differential equations, the exploration of generative design and so on. Very, very exciting areas in the future. Let me highlight just a few examples. So the first example I talk about is AI and machine learning, because that, as you saw in the surveys, right, very, very interesting in the aviation industry. So when we are looking at AI ML, we have identified 4 use cases. How can you improve customer productivity? When you run some of our solvers, right, like Fluent, the fluid dynamics solver, it is a very accurate solver, very robust solver, but you have to have a PhD almost to know exactly which of the 1,000 settings to use to get the maximum of our solver. For example, right, I mean, in turbulence modeling, it is well known that the full DNS modeling requires a long time, right? It may take a million hours of runtime, right? So at Fluent, what we do is we use Reynolds average Navier-Stokes, RANS methods, right? But RANS methods are good for steady state, they actually cannot model the real good turbulence modeling. So the question is, how can we use RANS modeling and use sort of the appropriate setting of these, what is called the Gecko parameters, generalized K omega parameters, right? To get it to the accuracy of DNS. So those are the kinds of things that we can actually do automatically through AI/ML. And we are actually partnering with a company, startup company, Geminas, to do that turbulence modeling. We've also looked at linear solver parameter tuning, the AMG solver at ANSYS using Bayesian learning. So those are examples of customer product. In the area of augmented simulation, we are looking at data-driven methods for neural networks, where essentially you train a neural network with multiple runs of simulation, and the neural network learns, sets all the neural network weights, and basically after that it runs through very, very fast. So there are data-driven methods, there are physics-informed neural network methods, there is machine learning-based PD solver methods, and some examples that I'm showing on the right are showing the numerical solution, the physics-informed neural network solution. These things run like 100 times to 1,000 times faster. We're also looking at the use of generative design to revolutionize engineering design. So lots of very exciting work going on in the labs at ANSYS, and these will eventually come in the form of products from next year. So very excited about this field. The other area I want to highlight is our work on high-performance computing. Over the years, our solvers, our mechanical solvers, fluid solvers, electromagnetic solvers, they are very, very accurate, but they take a long time to run to get to that accuracy. So we have always been focused on scalability, right? So our fluid solver, which is a picture shown on the left-hand side, is showing scalable HPC performance, right? With 200,000 cores. It is very, very hard to parallelize these cores. And what Fluent does is they explore parallelism at different levels. The highest level parallelism, which is parametric parallelization, sort of embarrassing parallelism. Then they do the next level, which is domain decomposition using message passing. Then they do at a node level, they do shared memory multiprocessing. And this year, we have been doing some amazing work in the area of using GPUs, graphics processing units, to accelerate our Fluent solvers. So our ANSYS Mechanical uses finite element analysis. That is actually much harder to parallelize. So this sort of is showing how it scales up to 512 cores. But where we are headed in terms of HPC is what is shown on the right-hand side. The future high-performance computing machines, right, are examples of machines are the kinds of machines being built by the Department of Energy in the US, right? There's this $600 million machine that is being built at Oak Ridge National Lab, another $600 million machine being built at Lawrence Livermore, and so on. These machines are being built by Cray, the supercomputer company, now part of HP. And these machines have, at those nodes, or fat nodes, they have multiple processors, multiple GPUs, and essentially you have to get the finest grain parallelism at those fat nodes level, and then across the nodes, they will run through what is called domain decomposition, MPI. We are working on our solvers on these futuristic machines at the Department DOE labs, and these same architectures will land up in the cloud providers in terms of HPC on the cloud. So we are working with Microsoft, Azure Cloud, AWS, as well as Google Cloud Platform on these kind of architectures. Very, very exciting areas. This brings me to another area which is very relevant to the airline industry. In the airline industry, people have talked about you have an aircraft engine, and if you can have a digital twin model of an aircraft engine, you could do predictive maintenance of that engine and say, hey, this is when you need to replace your engine or do some work on it, right? So the entire industry uses what is called data-driven analytics for digital twins. We at ANSYS, the last couple of years, have worked on simulation-based digital twins, meaning taking the asset, the engine, the blade, or whatever, and using Fluent at the 3D level, or structural mechanics at the 3D level, or electromagnetics, and use physics-based simulations. Those take a long time to run, and therefore what we have done is build reduced order models for the linear time invariant models, or for non-linear we have done static ROMs, dynamic ROMs, and build essentially system level models of that asset, can be an aircraft engine or a blade or whatever, right? And built a simulation-based model. Those are very accurate. The trouble is it takes a long time to do this, and if you try to do very simplistic ROMs, then the accuracy goes away. So what we have now done as part of our latest workflow at ANSYS in 2020 is to do hybrid physics and AI digital twins, and that is what is being shown on the picture. So we have partnered with a startup company called Geminas to take our physics-based solver twin builder with this data that you get from IoT gateways, we combine it into a very, very accurate and fast digital twin model. This brings me to the last part of my conversation, right? In the aerospace industry, people have been using different levels of simulation, right? And for different speeds and accuracy, right? At the lowest level, right? You can use physics-based simulation, 3D modeling, right? Using Maxwell's equations, structural equations, and so on to model things at the most accurate level. The trouble is very accurate, but it takes a long time, right? And therefore, people say, hey, instead of physics-based, let me do a system-level simulation, right? Which is less accurate, but is faster. At the higher level, you can do entire mission simulation. But as you move up, you essentially lose in accuracy. So it's the traditional way. You do it at a system level, you lose accuracy. Detailed level, you have a lot of accuracy. The trend is now doing integrated high fidelity mission analysis. And this is what we have done with our partner, AGI. You may have seen in the news that this week on Monday, we announced an acquisition, a definitive merger agreement to acquire AGI, Analytics Graphics Incorporated. And so what this is showing is, here is the cubic satellite, right? And it's going through, you're doing it at system level, and then you say, double click on, I need to do the actual antenna modeling using HFSS. So we are actually on the integration of the system level model, the digital machine simulation of a cubic satellite with this. Look at a hypersonic vehicle. Hypersonics are aircrafts that go at Mach 10 plus, right? So 10 times the speed of sound. When you have these kind of very high speed hypersonic gliders, right? And you are looking at the thermal signatures of this, how do you do it accurately through simulation? Looking at drone threat regions, how do you do that? So all of these are examples of simulation. So thank you very much for your attention. What we covered today is the aviation industry having to reduce costs. That is done through simulation. And we have identified some digital transformation capabilities through our ANSYS simulation. Thank you very much for your attention today.
Thank you, Dr. Prith Banerjee. The next guest of honor speaker has served several national and international corporations and a well-known supporter of SAE International and SAE India. Guest of honor, Dr. V. Sumantran. Dr. V. Sumantran is a holder of doctorate degree in aerospace engineering and a master's degree in technology management. Dr. V. Sumantran has had over 35 years of experience in the automobile industry and automotive industry in US, Europe, and India. Dr. Sumantran founded Celeris Technologies in 2014, an advisory firm to multiple domains, including automotive, mobility, digital transformation, aerospace, and technology. He also serves on several statutory bodies and advisory boards in India, Europe, and USA. He is an adjunct professor at Massachusetts Institute of Technology. The technocrat and strategist also co-authored a book, Faster, Smarter, Greener, The Future of the Car and Urban Mobility in 2017. I'm sure many of you will do a Google search about this book after his session. Dr. Sumantran serves on advisory boards of multiple Fortune 500 companies. He served as a special advisor to leadership of Renault-Nissan Alliance 2014 and 15. He is currently the board of directors in one of the famous airlines in India. He was vice chairman of India's second largest commercial vehicle manufacturer, Ashok Leyland. He was executive director of Tata Motors, chief executive of a car business in its very formative years. And not many of us know that he holds an aircraft pilot license. Very interesting. And he has always been supporting SAE India. Thank you, Dr. Sumantran. Over to you, Dr. Sumantran.
Ladies and gentlemen, it's really a pleasure and an honor for me to be here with all of you at SAE 2020 Aerocon. I'm speaking in my personal capacity, not related to any of the organizations that I'm affiliated with. But since I do follow this industry very closely, I do see that this is an extremely crucial time for aerospace and aviation. It's partly resulting from many megatrends. It's not just COVID alone. You know, COVID is a very recent in the last 9-month phenomenon. But even before that, the world has been seeing all kinds of megatrends, including a fundamental concern as to whether there is a slowdown or a cooling of the enthusiasm for what we felt was globalization. Globalization was seen as an important engine for the global economy, and there have been many parts of the world where people have said, is this the right thing? And that, of course, impacts aviation and aerospace immensely, because this is very much a global business. COVID, of course, more recently and over the last 9 months has dealt a devastating blow to so many economies. It's been a human scale and an economic scale of this pandemic. And of course, here too, aviation particularly has been very badly hit, because there are concerns about congregation of people, travel of people, both of which are extremely relevant to aviation and air travel. So we've seen across the world airlines facing immense financial stress, and we've also seen airplane makers similarly face immense financial stress. And we're all looking at ways to safely and quickly come out of this deep hole that we've been in. Related to the globalization currents as well as COVID, there have been other contributory factors more recently. In some ways, it has these two factors have contributed to elevated geopolitical tensions around the world. So whether one is talking about Hong Kong, or whether one's talking about China and Taiwan, or whether one's talking about China at the borders of India, or even Azerbaijan and Armenia, we have seen fissures develop in so many parts of the world, leading to elevated geopolitical tensions. And these tensions are further aggravating global economy and, importantly, global concerns for security. So both of these, again, are very closely tied to what aviation and aerospace sectors do. So these are going to have a very important effect going forward. If I now spend a few minutes thinking about India and aviation, I think we've come off a very, very successful chapter. Ever since privatization, and we've seen the proliferation of private airlines in this business, air travel has grown rapidly. And it has come to serve the kind of business needs that people have, and also social needs. I think travel and mobility are key elements in a society, both for economic outcomes as well as social outcomes. So we've seen tremendous enthusiasm for air travel, both for business travelers as well as leisure travelers. And even over the last 5 years, we've seen a roughly 12% growth for airline travel in India, which is roughly what people would expect, given the way in which our GDP has also been growing. But one thing that has characterized air travel in India, like many other sectors, it probably has a parallel with cellular communication. We have high structural costs, particularly in the case of airline travel, with very high cost of fuel, high cost of capital to buy expensive aircraft. But at the same time, we also have very, very cost-conscious customers. And so we have a very tight margin that we have to operate with in terms of very, very aggressive revenues, probably as aggressive, in fact, as my colleagues would say, nowhere else in the world can you fly for a couple of hours on a flight and pay not more than $50 or 3,500 rupees. So it's a very cost-conscious customer, and the airline has to serve this customer while dealing with very high structural costs and operating costs. But nevertheless, I think at least many airlines have found opportunities to blossom in this environment, and it has played it's played an important role in keeping the focus on efficiencies, operating costs, and productivity. And these have been important lessons we have learned. But even this industry and even these learnings are stressed when you deal with something like COVID. And we have seen at least many airlines, particularly the smaller airlines, being very badly hit by this prolonged period of low air travel and low load factors. But I remain an optimist as far as India and aviation is concerned, because we have a very, very healthy demographic for the country. And when we look at the next 10 years or 20 years, we have a lot of young people. As the economy will start to inevitably come out of COVID and start to grow again, I think we'll see a lot more of these people fly. We've got a business traveler section that is growing. And if you look at the projections, the analysts predict that over the next 10 years, India's fleet will more or less double, maybe go from something like 650 or so we have today to well over 1,200. Partly also because today the sector still remains very underserved given the size of our population. India has 0.1 seats per capita in terms of fleet capacity, which when you compare it with another developing economy like Indonesia, Indonesia has 5 times the amount of capacity that India has. So there's a significant amount of headroom. And when you look at the policies from the government, policies like UDAN, trying to make sure that we get more airports to operate around the country, we get more people in rural areas to travel. And this is, again, both for business purposes as well as for leisure and tourism. It's going to be a huge gain in productivity if a rural traveler can still travel to a big city, finish his or her business that day, and fly back at the end of the day. So I remain extremely optimistic about the outlook for aviation in India. And I think as we inevitably come out of this COVID crisis, we will begin to harvest the benefits of this trajectory. Let me switch now a little bit to defense and aerospace. Over the last 20 years, India has certainly been one of the larger importers of aircraft and military equipment across the world. And we have seen recently the kinds of geopolitical tensions I talked about has actually accelerated many programs and many acquisition programs. When we talk about the modernization of our air forces, we have seen across the spectrum, whether we're dealing with air power, India has recently brought in the Rafales from France, the Apache helicopters from the US. In logistics, we have very significantly upped capacity with the C-17s. And even for recognizing the very large coastline and our increasing priority for managing the vast sea lanes that serve India. The maritime surveillance fleet's been augmented by the P-8Is. So we've seen a very accelerated modernization, and I have no doubt this will probably continue. Even more encouraging for me is the acceleration of momentum for many of the indigenous programs. I know you will have Dr. Kota Harinarayana talk to you later today. A wonderful man who had a great role to play in getting the light combat aircraft, the Tejas, into production. And now we've seen advanced versions of that, including the Mark II, with significantly improved performance. And that, when you take that, the induction of that into the Air Force, along with the induction and the expansion of the use of the advanced light helicopter, I think we've got 2 workhorse platforms in India that all of us can be proud are the result of indigenous technologies and indigenous skills and talent. But I think we will have to see this grow and accelerate even further. We're already beginning to see the early flight tests of the light utility helicopter, something that we must commend HAL to doing. For a long time, we thought we would only have to import such aircraft or such helicopters. But kudos to HAL for moving very fast and getting the LUH out, and now it's already in trials in Ladakh. And also the HTT Turbo Trainer, giving the Air Force a primary trainer. Both are programs that have seen a lot of recent momentum. I'm very happy to see that. And covering the other side of aerospace and defense, we've seen in the news recently an acceleration of many of the missile programs, whether it is the air or the sea-launched BrahMos, the anti-radiation missile, the Rudram, and the subsonic cruise missile, the Nirbhay. All of these give us a sense of encouragement that hopefully this whole objective of becoming more self-reliant, upskilling our industry and upscaling our industry, and taking responsibility for more of the platforms that we should be taking care of as a large country and a large industrializing country. So here too, in the future, I am optimistic about the trends that we see in technologies. First of all, we're seeing across the globe a tremendous diversity of aviation platforms. The most recent Azerbaijan and Armenian conflict has brought to light the important role that drones and weaponized drones are playing in the battlefield. So everything from very small platforms to augmented sensor platforms with drones or light autonomous helicopters, all the way to more advanced weaponized systems is going to challenge the industry. And I say this in the context of Aerocon and the Indian aerospace industry. It's going to challenge us to, pick up speed and take confident charge of many more programs. At the other end, of course, there are the very complicated and highly complex platforms. India has shown, at least according to media reports, the serious consideration of India's options with a fifth-generation fighter, and as we see around the world, very rapidly even moving beyond the fifth-generation fighters to sixth-generation platforms, where there is a great degree of autonomy and unmanned performance that is being required of these platforms. So it is not uncommon, I believe, in modern defense theaters to be thinking about a convoy of aircraft with unmanned wingmen leading a squadron of aircraft or even a sortie of aircraft. This will challenge us to some of the advanced technologies that we need in sensor platforms, in control and control systems, and in the use of the advanced technologies of AI, in being able to operate platforms without necessarily having a human on board for every mission. Here again, with if we can truly tap the huge creativity we have in Indian talent, both on computers and AI and software integration, we can make even faster progress with these future programs. All in all, I think that for India, Aerocon is important because it brings together people who are enthusiastic about these subjects, both on the aviation side and on the aerospace side. And as we now consider this wonderful opportunity of things we have to work on, it's going to be a very productive, a very strategic, and a very important phase for India's aerospace sector. And I must once again commend SAE for putting together this platform and bringing all of us who have shared this passion together and remind ourselves of the wonderful things that lie ahead and spurring us on to faster and more meaningful progress. So I wish you all a very successful conference, and more importantly, stay safe. And we look forward to your contributions to India's aviation and aerospace sector. Thank you.
Thank you, Dr. Sumatran. That was a very inspiring and fact-filled speech. That marks the conclusion of our inaugural ceremony. The main portion starts now, the theme sessions. And before we introduce the technical committee chair, who will introduce the theme of technology theme sessions, I want to take your time to tell you what are the facilities available. We use TownScript 3D platform, and we've got facilities to look at the exhibition hall. Many of you would have visited, and then social lounge. You can chat with the other 516 people. Yes, we have over 500 attendees today. We also have exhibition hall. You can go and there are booths. You can download the PDF of our sponsors. ANSYS is the title sponsor. Dassault System is the principal sponsor. Infosys and MathWorks are the platinum sponsors. HCL Technologies, Hexagon are the gold sponsors. Moog and Hindustan Institute of Technology and Science are silver sponsors. So, ladies and gentlemen, I'm very, very glad to introduce Dr. G.V.V. Ravikumar. In fact, we mistakenly say Dr. Genuine, Valid, and Veracity Ravikumar. Just kidding. So, he is genuine. He gives a lot of value to us, and he has a lot of veracity. So, in a way, I would say he is the backbone of Aerocon 2020. He has built his technical committee from 5 different organizations, put together a program, and spent a lot of effort for SA India, for Aerocon 2020. He is the Associate Vice President in Infosys. He is also the head of Advanced Engineering Group in Infosys. He has served various engineering services companies. Now he is with Infosys, and we know him as Technical Committee Chair and the backbone of Aerocon 2020. Over to you, Dr. G.V.V. Ravikumar.
Good afternoon and good evening to all of you who are participating across the globe. I'm Dr. Ravikumar, head the Advanced Engineering Group of Infosys. I'm the chair of Technical Committee of Aerocon 2020. I would like to walk you through the technical program of this event. In line with the theme of the conference, Flying Through Turbulence, Reimagining Aerospace Industry, we have structured our program into 4 broad themes, 2 business and 2 technology. The first business theme is on reimagining aerospace industry in post-COVID era. The second business theme is on challenges and opportunities for safe and sustainable operations. The first technology theme is on technology landscape in post-COVID era. The second technology theme is on disruptive technologies in aerospace and aviation. Each of the themes will have 1 keynote presentation and 1 panel discussion. We will be covering the first business theme and first technology theme in day 1, the second business theme and second technology theme in day 2. We have distinguished speakers and panelists lined up for the next 2 days. I'm sure you will get immensely benefited from these sessions. You can post your questions on chat. We'll give answers either in this session or offline. Enjoy your sessions. Thank you.